Picture the Earth 66 million years ago. Lush tropical rainforests blanket the land, teeming with bizarre creatures from tiny feathered dinosaurs to giant flying reptiles. Life is warm, wet, and wonderful. Then suddenly the sky splits open, and a blazing comet or asteroid hurtles towards the planet. At first there's a bright flash like a massive fireworks, followed by a thunderous boom that shakes the ground for days. Giant fissures in the earth open up and buildings collapse as powerful shock waves rip through the landscape. Plumes of debris shoot into the atmosphere, blotting out the sun. This was the day the world changed forever, the day that wiped out the dinosaurs and ushered mammals like our distant ancestors into the Cenozoic era and ultimately led to the rise of humans. In this video, we'll explore the Chicxulub Impact, one of the largest cosmic events in Earth's history. We'll examine how it triggered a cascade of cataclysmic events that not only devastated the planet, but also fundamentally reshaped the course of life. To understand the full impact of this cataclysm, we have to consider both the immediate effects as well as the long-lasting consequences that rippled through the biosphere for decades afterward. First, let's look at the initial devastation wrought by the impact itself. When the object known as the Chicxulub asteroid struck Earth near the present-day Yucatan Peninsula, it was traveling at an estimated speed of 43,000 miles per hour. Upon impact, the energy released was equivalent to about 100 trillion tons of TNT, roughly 20 times the explosive yield of the largest nuclear weapon ever detonated. The initial fireball alone would have incinerated everything within hundreds of miles, just as the atomic bombings of Hiroshima and Nagasaki leveled entire city blocks. But even further away, the airburst would have generated tremendous heat, turning forests into firestorms that raced across the landscape. This intense heat ignited vast stores of methane gas trapped in the undergrowth, peat deposits, and shallow oil wells, creating massive flaming infernos that burned for weeks. Anything not consumed by the initial firestorm was quickly inundated by towering tsunami waves that spread outward in all directions. As the water receded, it left behind a vast inland sea. The wave heights would have dwarfed anything recorded in human history, reaching over 100 feet in some areas. These colossal breakers crashed ashore with incredible force, sweeping away trees, buildings, and animals alike. Along coastal regions, few structures could have possibly stood up against such a deluge. Even those fortunate enough to survive the initial impact and firestorm would likely have perished in the ensuing flood. But even as the fires burned and the waters rose, an even greater catastrophe was unfolding high above the earth. The impact sent up a gigantic cloud of debris, including pulverized rock, dust, and pulverized limestone. This colossal plume shot skyward, reaching an incredible height of over 12 miles. For perspective, that's nearly as far as a jumbo jet flies in an hour. As the plume ascended, it rapidly spread out, eventually blanketing much of the northern hemisphere in darkness. Sunlight was either blocked outright or bounced back into space, plunging the planet into an unnatural twilight for months. This sudden darkness had profound implications. It not only deprived plants of the sunlight needed for photosynthesis, but also disrupted global climate patterns. Temperatures plummeted as much as 60 degrees Fahrenheit below normal in some areas. Without the moderating influence of the sun, the Arctic and Antarctic regions became frigid wastelands. But the absence of sunlight caused more than just freezing temperatures. It also triggered a dramatic shift in precipitation patterns, leading to an abrupt end to the warm Cretaceous period and ushering in what would become known as the Age of Mammals. Before we continue, let's take a moment to appreciate the rich tapestry of life that existed before the impact. The late Cretaceous was a period of remarkable biodiversity. Herbivorous ornithischians like Ankylosaurus roamed the earth, while agile carnivores like Velociraptor hunted in packs. The skies were dominated by giant flying reptiles called pterosaurs, including the gargantuan Quetzalcoatlus. which had a wingspan rivaling a small aircraft. In the oceans, fearsome marine reptiles like mosasaurs swam the seas, feeding on smaller creatures. And don't forget the dinosaurs. These magnificent beasts had evolved over millions of years and come in a variety of forms, from the towering Brachiosaurus to the ferocious Tyrannosaurus rex. Their reign as the dominant terrestrial animals was nearing its peak, yet they, along with most other life on Earth, would soon be extinguished. Back then, Earth's environment was very different. Global temperatures were higher, leading to higher sea levels and widespread tropical climates. Many parts of the world that are now dry and barren were once covered in lush vegetation. As a result, Earth's surface looked vastly different. Continents were positioned differently, and vast archipelagos dotted the world's oceans. Life on land and in the seas had adapted to these conditions. But the impact would bring about an abrupt and drastic change in Earth's environment. The collision triggered massive volcanic eruptions in areas like the Deccan Traps in India. These eruptions spewed tens of thousands of cubic kilometers of ash and gases into the atmosphere, further blocking sunlight and contributing to the cooling effect. Conditions became so frigid that snow fell as far south as the Yucatan Peninsula and northern Africa. But beyond the initial impact and climate shock, a new and insidious threat began to emerge, one that would haunt survivors for years. After the impact, the global climate system was thrown into chaos. Temperatures fluctuated wildly, veering from unseasonable heat waves to sudden deep freezes. But perhaps even more catastrophic were the effects on precipitation. The delicate balance of evaporation, condensation, and rainfall that sustains life was utterly disrupted. For example, when water vapor in the atmosphere condensed, it formed clouds that blotted out the sun and precipitated as rain. This downpour was so relentless and prolonged that it caused widespread flooding. Regions that were once parched deserts became inundated, while places with long histories of rainfall turned into swamps. But as the relentless rains continued unabated, they leached massive amounts of sulfur compounds from rocks and soil. These compounds, including hydrogen sulfide, then dissolved in the water, turning the rain painfully acidic. The pH of this acid rain was as low as 2.8, which is even more acidic than some of the strongest industrial chemicals. Acid rain of this magnitude had devastating effects on both terrestrial and aquatic ecosystems. It killed off countless species of plankton, fish, and amphibians. Decades of ecological progress were wiped away as entire ecosystems collapsed. Some animals were able to adapt to the changing conditions, but many more simply perished. Even if the acid rain hadn't been so pervasive, the long winter alone would have been devastating. Winter lasted for 2 years without any interruption. No spring ever came. And the persistent darkness deepened the chill. Creatures that couldn't generate body heat, such as most reptiles, succumbed to the cold. Those that did not freeze to death slowly perished from starvation. This extended period of darkness and cold caused the extinction of approximately 75% of all plant and animal species on Earth. Dinosaurs, with their large bodies and limited ability to regulate temperature, were particularly vulnerable. The impact effectively ended the Cretaceous period and ushered in the Paleogene. The Cenozoic era, often referred to as the Age of Mammals, began. But even though life found a way to persist and evolve after the Cataclysm, the scars left by the impact ran deep and lingered for centuries. The environmental fallout from the impact profoundly shaped the trajectory of evolution. The sudden disappearance of dinosaurs and other large creatures created ecological vacancies that allowed mammals to diversify and expand into new habitats. As the world slowly began to recover, new species arose to fill the void. While the impact had immediate and devastating consequences, it ultimately proved to be a catalyst for the rise of new life. After the dust literally settled, the world was irrevocably altered. Entire ecosystems had collapsed, leaving behind a haunting silence where once a cacophony of life had thrived. But even in the darkest hours after the impact, the seeds of recovery were already being sown. Microorganisms in the soil, remarkably resilient, began the slow process of rebuilding the food chain. Tiny plants known as vascular cryptogams were among the first to colonize the altered landscape. They were soon joined by early mammals and birds whose ancestors had survived by sheltering in burrows or caves. Over millions of years, these hardy creatures gradually diversified, filling newly available niches and giving rise to the world we inhabit today. Despite the horrors of the impact, life not only rebounded, but did so in a completely new and unexpected way. As we reflect on the Chicxulub Impact, we are reminded of the fragility of life on Earth. Yet we also see a testament to the tenacity and adaptability of living things. From the smallest microorganism to the largest animal, each plays a role in the intricate web of life. And while one catastrophic event can reshape the biosphere in an instant, life finds a way to not only endure, but also to flourish anew. In the aftermath of the impact, the planet entered a prolonged period of recovery, one that would span millennia. But even as life struggled to rebuild itself, it did so in a dramatically altered world. The cascading effects of the impact triggered profound changes in geology, climate, and ecology that fundamentally reshaped the course of evolution. As the dust settled and the world began to heal, it did so in a form that was both familiar and strange. New species arose, entire ecosystems rebuilt themselves, and the stage was set for the rise of new life.